As we discussed before, we have worked with several types of data so far, categorical data and quantitative data. In our last video, we talked about dot plots. Today, we're going to be talking about stem plots. So recall that the method of analysis that we use to look at a data set depends on the type of data we're trying to analyze, whether it's categorical or quantitative, and within the quantitative realm, different graphs have different advantages. So we're going to start off by talking about stem plots or stem and leaf plots, which you saw in middle school. Stem plots give us a quick picture of the distribution we're looking at while actually including real numerical values. So these data below represent the responses of 20 female AP statistics students to the question, how many pairs of shoes do you have? And we're going to construct a stem plot for these data. So here we have a data set that represent the responses of 20 female AP statistics students to the question, how many pairs of shoes do you have? And we're going to construct a stem plot for these data. So we're going to separate each observation into a stem, which consists of all but the final digit of a data point, and a leaf, which is the final digit. We write the stems in a vertical column with the smallest at the top and draw a vertical line at the right of this column. So my stems come from the tens place of each of these data points, and then I'm going to add in my leaves. My leaves come from the ones place of each of these data points. So it didn't happen in this case, but we don't skip any stems even if there's no data value for that particular stem. So let's say this 49 observation didn't exist, this 49 data point, we would still list the 4 as a stem, we just wouldn't put any leaf next to it. So we wrote each leaf to the right of its stem, and from there we need to rearrange our leaves so that they're in numerical order. So I take all of these 9, 3, 3, 3, 5, and I rearrange them in numerical order, 3, 3, 3, 5, 9. From there, I have to add a key that explains what my stem plot actually means. So the 4 with a vertical line, 9, represents a female student who reported having 49 pairs of shoes. On the AP exam, if you don't list your key, you actually don't get any credit for your stem plot. So here we have the steps for making a dot plot summarized. Go ahead and add those to your notes. This will be a really important reference for you later on. Hit pause in the video and capture those now. Okay, so now I want you to try this. So hit pause and make a stem plot for the male heights in the data set listed below. Nice work. Here's your answer. Check it against yours. Make sure to use your grading pen to evaluate your response. Make sure that you have that key included in there, because if you don't have the key, you don't get any credit. So we asked 20 male students the same question about how many pairs of shoes they own, and their data is shown right here. Pardon that this is a busy slide, right? So if we make a stem plot for the male data, we get something that looks like this, right? And there's not that many observations, so it's a little bit hard to see what the distribution looks like. So what we can do to get a better picture of how male shoe ownership looks is we can do what's called splitting stems. So what we do is we split up each stem into 2 stems, and for our leaves, we're going to put the leaves 0 to 4 with my first 0 stem, and 5 to 9 with my second 0 stem, and I'm going to keep doing that here. There's no right or wrong way to split stems so long as you keep it consistent. So for every single one of these data values, the stems 0 to 4 will go with the leaves 0 to 4 will go with the first stem, and the leaves 5 to 9 will go with the second stem. So when we do that, we get a much better idea of what our stem plot and what our distribution for males actually looks like. In this case, we're really able to see with the male distribution that we have a single peak and a cluster of values between 4 and 14 pairs of shoes owned, and that these data points are actually outliers. So now let's say we wanted to compare male shoe ownership to female shoe ownership. I can use a back-to-back stem plot, that's what this is called, and back-to-back stem plots compare two distributions as long as they have a common stem. So we had to split stems for our female data set, which we didn't do before, but we did it here. And this allows us to see my distribution of male shoe ownership versus my distribution of female ownership. Be careful when you're reading this. So male shoes are pretty easy to read. One person owns 10 shoes, another owns 11, another owns 12, another owns 14. But when you're reading the left side of a back-to-back stem plot, you have to be aware that the stem really belongs before the leaf. So for this first female, she doesn't own 31 pairs of shoes, she owns 13 pairs of shoes. This first data point here, this woman owns 24 pairs of shoes, not 42 pairs of shoes. So now I want you to try this. Pause the video, and you are going to use the same data set that you started to use before about height. You are going to make a stem plot for males where you split the stems, and then a back-to-back stem plot comparing male and female heights. Pause the video now to do that. Here are your answers. Compare your work to the answers here, and make sure you correct your work using your grading pen. A few tips about making stem plots. So stem plots don't work well for large data sets because it's just too much to capture all of the individual stems and leaves. So use those at your discretion for a relatively small data set. There's no magic number of stems to use, but 5 is a pretty good minimum. So if you have fewer than 5 stems, you're definitely going to need to split stems. And if at any point you have more than 5 stems, but you don't think that it gives you a good representation of your data, you can always split stems there as well. If you split stems, be sure that each stem is assigned an equal number of possible leaf digits. So I talked about this before. If you're going to split each stem into 2 groups, your first stem would receive the leaves 0 to 4, and your second stem would receive 5 to 9. You just have to make sure that it's the same number of possible leaves for any given stem. So when data have too many digits, you can get more flexibility by rounding the data so that the final digit after rounding is suitable as a leaf. So for instance, if we're reporting salaries, right, $93,834, I'm not going to make a different leaf for each dollar value. It doesn't make sense. So what we will do is we'll use 9 as a stem, and we will round all the numbers after 3 to make our leaf. And so my leaf would be 4. This should say leaf, not leaf. Then my key would state that 9 vertical line 4 represents approximately $94,000. Okay. A quick tip: you're going to be asked to describe shape, outlier, center, and spread for stem plots, and something that makes this easier is to turn the stem plot on its side, making sure that you have the lowest numbers to the left. When we do this for a back-to-back stem plot, we actually have to do it twice. I'm going to do it once such that the after distribution is on top, and then I'm going to do it another time such that the before distribution is on top. But notice I had to flip it twice because I need my 6 to be all the way on the left. Nice work. Go ahead to your online check for understanding.